Hello, I'm Rob Abbott and welcome to the course Introduction to Neural Networks. In this video, we're going to answer the question, what is a neural network? By the end of this video, you should be able to name the layers and components of an artificial neural network and state their function, describe the role of weights in determining how an artificial neuron fires, and explain why inputs to a neuron are scaled between 0 and 1. Let's get started. The original motivation for computational models of neural networks found in animals was to mimic the biological processes in the brain, with the ultimate goal of creating an artificial intelligence that functions similar to human intelligence. In animals, the nervous systems are composed of biological neural networks, consisting of vast interconnections of neurons throughout the body. These networks make up the peripheral and central nervous systems of humans and other higher-order animals. A typical neuron consists of three components. The body of the neuron is called the soma. It is where the cell nucleus resides and is responsible for controlling neuronal function. The soma receives stimuli from its dendrites, which connect to other nerve cells. The soma also generates output stimuli which are emitted from the axon of the nerve cell. The axon of a nerve cell connects to the dendrites of other neurons at synapses. These connections between neurons exchange messages through the flow of chemicals called neurotransmitters. Neurotransmitters can either facilitate or amplify the transmission of a signal, or they can inhibit the signal flow. Think about how you initially feel a strong, sharp pain if you stub your toe on a chair, but how that pain subsides after a bit. This allows your brain to focus on other stimuli by turning down the volume of the signals from your toe. Artificial neural networks are models of the biological neural networks that we just examined. Like typical neurons, artificial neurons have one or more inputs that correspond to the dendrites of a neuron, and has one output that corresponds to the axon of a neuronal cell. The output of an artificial neuron may be connected to the inputs of other neurons in a method similar to biological neural networks. Each input to an artificial neuron is multiplied by a weight that controls how much that input contributes to the activation of the neuron, similar to how neurotransmitters regulate the action potential of animal neuronal cells. Finally, the artificial neuron has an activation unit that corresponds to the soma of a biological neuron. This activation unit is responsible for aggregating the inputs into the neuron and determining whether or not to fire its output to the axon and, in some cases, to what degree the output is activated. This is controlled by the activation function of the artificial neuron. A simple artificial neural network consists of three layers. The first layer is the input layer. This contains all of the inputs that feed into the activation unit of the neuron. It is important to note that, in most cases, the inputs of a neural network must be scaled to a range of 0 to 1. This is to prevent any disproportionately large inputs from dominating the activation function of the neuron. The second layer is the hidden layer. It also consists of three distinct components. The first component is a vector of weights between 0 and 1. Each of these values is used to scale the importance or contribution of each input, or feature, to the production of the output stimulus of the neuron. The second component of the hidden layer is an aggregation mechanism. This aggregator takes the scaled value of each input and usually sums them to produce a combined input to the neuron. The third component of the hidden layer is the activation unit or activation function. This piece compares the input to a threshold value to determine if the neuron should fire and to what degree it should fire. The final component of the artificial neuron is the output layer. In most simple neurons, the output of the neuron produces a value between 0 and 1. In our next section, we will examine how a neural network functions and produces an output from a set of input stimuli. I'll see you then.